Alright, in this video, the objective will be to uh, go between or convert between standard notation and scientific notation. And scientific notation is a special way of writing numbers that you'll use in science class and many other math applications or science applications. And it's a different way of writing really big numbers or really small numbers, and it uses exponents with a base of 10. And so let's just do a really quick. If we have 10 to the first power, we know that is 10. And if we have 10 to the second power, we know that's 10 times 10, which is 100. And if we have 10 to the third power, well, we know that that is 10 times 10 times 10, which is 1,000. Now, if we have a negative exponent, for example, 10 to the negative 1, well, that actually means 1 over 10. That's what that negative exponent means there. And so if we have 10 to the negative 2, that will be 1 over 10 times 10, which is 1 over 100. And 10 to the negative 3 power is 1 over 10 times 10 times 10, which is 1 over 1,000. So there's a very quick lesson about negative and positive exponents with a base of 10. So in order to convert between from standard notation to scientific notation, what you want to do is, we'll using the example, let's say 7,320,000. Now, we're going to change this number into scientific notation, and again, scientific notation is basically a number, a decimal, with only one single digit in the ones place. So what we need to do is we need to start with where the decimal currently is in this number, and then we're going to move it over however many spots it takes in order to get a one single digit in the ones, and then the decimal place, and then the rest of the decimal. So we're going to move this one over, in this case 1, 2, 3, 4, 5, 6 spaces, okay? 6 decimal places. And so now we're going to write it as 7.32, and now this is going to get multiplied by the base of 10, and the exponent here, it's very simple, is the exponent is going to be the exact number of spaces that you move to get to this decimal. And so that would be 6 places, so that is 6, the exponent would be 6. So we have 7.32 times 10 to the power of 6. And if you were to multiply that out, you would get 7.32 times, and 10 to the 6th power is 1 million. And so you have 7.32 times 1 million. That, in fact, gets you back to the original number. So this is the scientific notation for this original number. Okay, let's do one more. How about if we have 6, 2, 8, 5, let's say. Well, again, you just start here. You move the decimal over 1, 2, 3 places, and then you have 6.285 times 10 to the power of 1, 2, 3. Okay? Now, let's say you want to go the other way. Let's say you have a small number, such as 0.0048. Now, this time, you need to make this small number, and you need to move the decimal over until you have one digit in the ones place. So we're going to move this time to the right, 1, 2, 3 spots. So we have 4.8 times 10. And since this was a really small number, we can make this, we know that the negative exponents designate small numbers. So we move 3 spots, so we're going to give this a negative 3. Now, some people memorize, if you're going to the left, it's negative, and the right, positive, or however that works out. But to me, I think the easiest thing to do is to see, hey, was this a small number? Okay, that's going to be a negative exponent. Was this a big number? That's going to be a positive exponent. I think that's easier than trying to memorize some rules like that. Okay, now let's go back the other way. Let's go from scientific notation, for example, 2.61 times 10 to the fourth power, and let's try to make this into standard form. Well, we have 2.61. We're going to move this decimal over to a positive exponent, so it's going to be a bigger number. So we're going to go to the right. 1, 2, and then there's nothing here, but we're going to go 3, 4 spots total. And now we have to fill in the zeros, so we have 0, 0. So we'll read that we will rewrite this as 2, 6, 1, 0, 0, and then we know that the comma goes here, so we have 26,100. And last example, we'll go 3.6 times 10 to the negative 5, okay? And we know that this is going to be a really small number, so we'll write 3.6, and we'll start moving our decimal over to make this a really small number. So we'll go 1, 2, 3, 4, 5. And now look, it's I want to point out that it's a lot easier to do this when you have graph paper. Okay, so each one of those units, you won't have to get mixed up and see, was that 1 over or 2 over. Let's put in the zeros here. 1, 2, 3, 4. This is where our decimal is going to go. Make sure that this is the decimal. And then we know that typically when we rewrite decimals, we have a 0.0 something or a 0 in the beginning too. So that doesn't really count as one of them. But now we have 0.4 zeros after the decimal, and 3 and 6. Okay, so what's that going to be? Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Okay, so here we have this now in standard form. Okay, so let's see, what can we say as a summary for this? Well, I guess to convert between standard units or standard notation and scientific notation, you just simply move the decimal however many spots the exponent was. If it's a positive exponent, you're going to move it so that it's a bigger number. If it's a negative exponent, you're going to move it so it's a smaller number, and then you're going to put the decimal in the correct spot according to those rules. Okay, and again, if you want to rephrase that in a clearer way for you, you are more than welcome to do so. I do hope you enjoyed this video, and I'll see you next time. Bye.